Bismillahirrahmanirrahim. Assalamualaikum and very good morning. Okay, today I'm going to explain about IP version 6. And this is the other version of IP. So we have discussed before IP version 4. And now I'm going to explain about IP version 6. So why IP version 6 is very important nowadays. So there is some reason that I will explain later on. Okay, so in this chapter, we are going to have a look on the reason why IPv6 was introduced, the packet structure of IPv6, the addressing, the transition mechanism, current issues, and conclusion. Okay, why IPv6? We already have IP version 4, but why we need to implement version 6? Okay, so first have a look on what is the current issue in IP version 4. Okay, version 4 of IP was published in 1981, proven to be robust, easily implemented, and interoperable. So the age is 81 now, almost 40 years old. Incredibly successful because today's internet run over IP version 4. As we know that version 4 consists of 32-bit or provide more than 4 billion IP addresses, 2 to the power of 32. And over here 2 to the power of 32. So the allocated address by class, A, class A, class B, and class SC and D. But what are the issue of IP version 4? As we know that IP version 4 didn't anticipate the exhaustion of the address space. The backbone router maintained large routing table, routinely over 85,000 addresses. The need for simpler configuration. User requirement nowadays, mobility, security, and quality of service. Okay, a long-term solution. So they have done a research to produce a IP next generation. So the work start on 1991. Okay, 1995 IP version 6 was selected. It is evolutionary step from IPv4. It's not really it's not very different from version 4 because it is a evolution process. So 1996 IP version 6 was standardized. Okay, why we need to have to use IP version 6? First of all, IP version 4 require network address translation net router from private network to public network. So local address space will be translated to small number of globally routable IP addresses. Is there any problem with net? Okay, so it got some problem. First is it break globally unique address model. DHCP IP versus MAC. Then it break address stability. It break always on model. It break a peer-to-peer model. It break some application. It break some security protocol. IPsec not compulsory. It break quality of service function. Introduce a false sense of security and introduce hidden costs. Okay. So IPv6 provide plentiful global addresses, implies no net required to implement version 6. So it will eliminate all the problem that been introduced by using a net. Okay, the next reason why IP, which this is the major changes in IP version 6, which will be the reason why IPv6 need to be implemented. First, IPv6 provide larger address space because IPv6 are 1 to 8 bits long versus 32-bit long for version 4. So avoid the potential exhaustion of IP address. Administration of medium and large networks simpler by avoiding the need for complex subnetting scheme. There is no subnetting scheme required in IP version 6. Stateless auto configuration of hosts. So hosts can be configured automatically when connected to a root IP version 6 network. Multicast, part of the base specification in IPv6. It is part of the specification of IPv6. So unlike IPv4. Jumbogram. In IPv4, packets are limited to 64 kilobyte of payload. When used in link with MTU larger than 65,000 octet, IPv6 has optional support for packet over up to 4 GB. Okay, network layer security, IPsec, the protocol for IP network layer encryption and authentication, is an integral part of IPv6. It supports mobility. It has lack of checksum. So IPv6 has no error checking in its protocol, but instead relies on the link layer protocol to perform error checking. Okay, the changes in the packet structure. Okay, so we have packet structure for version 4 and packet structure for version 6. So it reduced the number of fields. So in terms of the header, it contains 20 octet for version 4. Version 6 contains 40 octet. In terms of field, IP version 6 is lower, which is contain 8 fields. So it will be more efficient to be processed. So you can see the changes between the packet structure of IP version 4. The blue the blue circle means change. The dotted line means remove. So it has removed four about 1 2 3 4 5 6 7 field from version 4 to version 6. Okay, the structure, this is the explanation in detail. It composed two main parts, header and payload. So header contain the version number, traffic class, flow label, payload, next header, hop limit, source and destination address, which will be represented by 1 to 8 bit. If compared to IP version 4, it's only contain 32 bit. So it provides larger address space. So based on this packet structure, IPv6 packet structure, it's enhanced performance because it has fixed size of IPv6 header and then fewer field in basics header, so faster processing, efficient option processing, option field process only when present, processing of most option perform only at destination. Okay, enhanced performance, okay, remove checksum, no fragmentation in the network, and minimum link MTU is 1280 byte compared to 64 byte in IPv4. Okay, this is the addressing scheme, the notation. So IP version 6 contain 1 to 8 bit. So use hexadecimal value of 16-bit pieces of the address. The this double dot indicate multiple group of 16-bit of zeros. It can be used only once. Okay, and let's say you have a multiple group of zeros. You can simplify by using this symbol. Okay, but it can be used only once. Once you have used here, you cannot simplify this one, and you cannot use the same symbol over here to replace this one. Okay, so instead you can just write like this. Okay, the IP address is represented like this. So IP version 6 address and the prefix length over here slash and the prefix length. Okay. Okay, the IP address structure formed from a combination of the prefix and interface ID. This is prefix, this is interface ID or the MAC address of the MAC address. It will be combined with the MAC address. Prefix representation. Okay. Routing prefix for routing topology. Node identification. Interface identifier. Okay. This is referring to the second part of the IP address. These are the basic address type. So we have unicast, anycast, multicast. So what is the difference? Unicast is an identifier for a single interface. A packet sent to a unicast address is delivered to interface identified by the address. It is one-to-one. Anycast is one-to-one as well. But the address, the identifier for a set of interfaces. This is for a set of interfaces. This is for a single interfaces. A packet sent to anycast address is delivered to one of the interfaces identified by the address. This is for router only. Multicast identifier for a set of interfaces. Okay. A packet sent to a multicast address is delivered to all interfaces identified by that address. And this is one-to-many. And this is one-to-one. Okay. Transition mechanism. And this is the process or the flow and the process of moving from IPv4 to IPv6. So the transition until IPv6 completely supplant IPv4, which is not likely to be happen in the foreseeable future. Number of so-called transition mechanisms are needed. The transition is required to enable IP-only hosts reach IPv4 services and to allow isolated IPv6 hosts and network to reach IPv6 over IPv4 infrastructure. We use different version of IP for different infrastructure or services or hosts. So the transition mechanism, the first one is dual stack. And since IPv6 is a conservative extension of IPv4, so it is relatively easy to write a network stack that support both versions while sharing most of the code. So we implement them together at network layer. So this is dual stack. Tunneling. Okay, we have network that implement version 6 but use version 4 tunneling. So tunneling consists of encapsulating version 6 packet within IP version 4. So in effect, using IPv4 as a link layer for IPv6. Proxying and translation. When IPv6 only hosts need to access IPv4 only services. So this is different version of IP address. Here use different version, so they need a translator to allow them to communicate. So IP version 6 still got limitation because it got some issues. First is the implementation issues, dual stack, transition mechanism, forwarding software in current IPv4 routing system, design and implement IPv6 multicast forward module. So this is the implementation issue. You got security issue as well, dual stack related issue because it combined version 4 and version 6. Header manipulation issues, mobility, flooding issues. In conclusion, Okay, do we need IPv6 right now? Okay, so we give you a scenario. IP version 4 addresses are becoming increasingly scarce. In North America, 74% of the allotted address. Europe, 17% of the allotted address. Use Asia, 9% of the allotted address. So a little arithmetic. Population in China is 1.3 billion. Usable global IP addresses provide 3.7 billion. So, in worldwide, about 65% of global IP address is already allotted. So the remaining 1.3 billion could be depleted by China only. So 1.3 billion is over here. So it's look like we already use all the addresses provided by the IP address for global IPv4 addresses. So that's why furthermore, but before that, and before I made the conclusion, so the internet is secure enough. So in terms of security, 70% of Wi-Fi access point run without encryption. 86% of consumer keep sensitive health in their computer information. 91% of users have spyware on their home computer. Very few users understand security risks. Modern firewall is not so effective. But IPv6 offer the opportunity for true end-to-end security. So these issues, all of these issues can be overcome by using IP version 6. Okay. The next thing is transition of IPv6 will be complicated and expensive. So let's look at this point. IPv6 will operationally cheaper. Why? No net, easier to acquire, design much simpler, integration much easier for readdressing. Okay, and this is if we consider in terms of cost. Okay, when we implement IP version 6, we will fix the cost. We will fix the cost because no net is required. Okay, majority of the transition cost is over here. So it requires some cost for the transition, system management, education, and integration. But later on, it will remain. It will reduce the cost because we don't need net router anymore. But if we still using the IP version 4, we are increasing. The cost will be increased from time to time. So in conclusion, IPv6 provide increased address space, provide efficient and extensible IP data grid, improve host and router discovery, easy to use, plug and play, enhancement for quality of service, improve mobile IP support, and provide better in terms of security because IPsec is mandate, coexistent with IPv4, extensibility of the architecture.